In this short but informational presentation, you will learn about crashing the critical path method schedule in Microsoft Project, a back to basics way of working. Here's a typical project we find our customers facing routinely. Finish the project before a required due date. It may be a factory changeover to update the product line, hospital upgrade, a power plant outage for maintenance, a steel mill or refinery shutdown for expansion. This sample problem uses the requirement to update an office of a newly hired university dean before the dean arrives. The project must be finished before the original planned arrival by the dean on June 1st. Engineering drawings or pictures are worth 1,000 words. In many project environments, we can visually see a representative existing condition and the team's finished goal. Here we have a layout of the existing dean's office with the new dean's architectural goal. Cost loading project activities. The estimated project value is about $3 million. Many simple projects can be managed using a list of tasks, as in progressive agile processes, providing value along the way. Experienced project managers know performing work based on task lists alone will not forecast a finish date, nor are task lists an effective tool to identify priorities based on a critical path. The first planning attempt shows the work is too much to accomplish before the new dean arrives on June 1st. A good critical path method scheduler can help set up an efficient logical network to perform the work based on sequential logic, resource, work requirements, and physical constraints between the major work items themselves. After planning sessions, the PM, scheduler, university team, and craft superintendents arrive at a workable plan that meets the time requirement. Using the project management body of knowledge version 6 and earlier predictive tools, this project can be completed in under 5 months, reducing the project timeline by 1 month and 1 week from July 2nd, as originally forecasted with a waterfall type schedule. At this point, the dean has her new office based on a targeted June 1st start date. News develops that the new dean will arrive early and expects a finished office to function. The question is, how do we shorten or crash the schedule? The current schedule finishes May 20th. The dean's updated arrival is now May 1st. As in the real world, project teams need to be able to respond to changing conditions, needs, and priorities. Utilizing total cost management and predictive CPM techniques, the project team can successfully shorten the project schedule, accommodating the dean's new arrival on May 1st. Examining the baseline schedule, the question is how to most effectively shorten the schedule or crash it from May 20th to May 1st. Let's utilize total cost management and the critical path to shorten the schedule. Schedule crashing, additional resources, or overtime to shorten planned durations of existing tasks. That costs money. One should not approve overtime for everything. If the work is not on the critical path, overtime on those tasks will not shorten the schedule. The goal should be spend the least amount of money, but shorten the project to finish in time for the dean's updated arrival. Schedule fast tracking, i.e. overlapping tasks to be performed concurrently, has already occurred for the baseline. Schedule crashing. Spend more money by approving resource overtime or adding additional resources on tasks, thus spending more money than originally planned. Assuming one can shorten activities by 30% if 1.5 times the normal costs are applied. Some activities cannot be expedited or crashed, such as funding approval, permit, and inspection activities. In our example, the project manager and the scheduler look at tasks and the potential of costs accommodating a new dean's arrival. This predictive analysis tool is not press the magic button. It requires cost-loaded schedule and analysis of activities and their costs in conjunction with the schedule's critical path. Focusing on total cost management, looking at the critical path and costs to crash, the least expensive activity to crash is coordinate and move out. 5 days at $6,100 normal cost, but that activity is not on the critical path. The next least expensive activity to crash is activity 14, coordinate and move in. 10 days can be shortened to 7 days, increasing the normal cost of $12,000 upwards of $18,840. Ultimately, the PM would request from the owner budget authorization increase of $6,157 to shorten the renovation by 3 days. Originally, the dean's office renovation can be completed in 100 working days for about $3 million. The timing is seen with the black lines at our baseline. However, approving overtime on the critical path for an additional $1.2 million, the project's completed April 16th, in plenty of time for the new dean's May 1st arrival. However, the inexperienced project manager may want to propose the extra $1.2 million to crash this schedule, meet this timeline, and complete this work needlessly. Project owners need to be aware of the sensitive critical path cost-time relationship. Notice spending $1.2 million crashing all permissible critical path activities will shorten a schedule for completion on 4/16. Yet, predictive, back-to-basic way of working lets transparently visible facts permit projects, teams, and owners to make good choices. How so? The new dean plans to arrive May 1st. Just $247,000 can be spent. Additionally, accelerating the schedule by 20 working days, finishing just in time. Notice Activity 5, A&E drawings and specs, Activity 9, demolition, Activity 10, rough install, and Activity 11, finish install, are not approved for a 30% schedule crash with an estimated 1.5 times their original costs. Presenting this what-if analysis to the owner for their decision results in saving $1 million, allowing the owner the flexibility to renovate other required facilities or invest the monies in other operations. Predictive, back-to-basics way of working does examine the critical path with the potential resulting total costs, providing the project manager, the customers with accurate project what-if analysis. In summary, consider selective overtime for expediting and crashing work. Rely on a cost-loaded critical path method schedule to prioritize and optimize the critical path work. That concludes this informational lesson on predictive ways of working, critical path method, and total cost management. Thanks for watching. Please like and subscribe to ACM for helpful management practices. Should you or a project owner find themselves having to shorten a schedule, do not fall into the trap, quote-unquote, overtime for everything. Indeed, understand the best tools available for effective ways of working.